The structural foundation of the software industry is currently being written at a speed that was physically impossible 12 months ago. This acceleration is driven by a practice called vibe coding. Instead of manually typing out lines of syntax in languages like Python or React, users describe the application they want to build using plain English prompts, and an artificial intelligence generates the full codebase. This split-screen chart illustrates the speed of this adoption. Looking at the recent cohort for Y Combinator, a prominent startup accelerator, 25% of their newly funded companies now possess codebases that are 95% AI-generated. The appeal is pure velocity. Non-technical founders are bypassing the traditional hiring process entirely. They are sitting down with a tool, describing a product, and deploying a functional MVP in hours instead of months. An MVP, or minimum viable product, is an early version of an app used to test a concept with real users. The historical barrier to software creation has collapsed. The ability to build complex digital products no longer belongs exclusively to those who spent years studying computer science. The leverage has shifted directly to the people generating the ideas. But that miraculous speed conceals a dangerous reality regarding the actual quality of the output. This chart shows that the speed comes with a cost. Data from Veracode and Wits University reveals that nearly 50% of AI-generated code contains known foundational security vulnerabilities. This creates what researchers call the illusion of competence. Because the AI is highly capable of generating code that compiles flawlessly and looks perfect on the surface, users assume the underlying structure is equally sound. It rarely is. For an individual building a personal weekend project, a fragile structure is an annoyance. For heavily regulated businesses in finance, healthcare, or public services, deploying these unverified applications creates a ticking time bomb of data exposure and compliance failures. Every company looking to adopt these tools now faces a difficult calculation, determining exactly where vibe coding acts as a prototyping superpower and where it becomes a massive liability for long-term scalability and security. The vibe coding experience usually begins with a massive dopamine hit. You type a single descriptive sentence, and within seconds, the AI generates a beautiful, highly polished user interface. Because the visual gratification arrives so quickly, users routinely skip the most crucial step of software design, explicitly defining their data structures and planning how information will actually be stored in the database. The friction hits a few days later. When the user attempts to wire up complex back-end data routing, like connecting a user profile to a specific payment history, the generated front-end UI suddenly lacks the proper data hooks to function. This triggers the prompt loop. The AI tries to connect, breaks the internal logic, and throws an error. Because the user lacks the foundational coding knowledge to understand the error, they simply paste the error back into the prompt. The AI guesses again, breaking something else. This flowchart contrasts expectation against reality. Users expect the straight line at the top, but rewiring a database after the interface is finalized forces the project off the rails, resulting in a chaotic cycle of endless debugging and a complete rebuild of back-end logic. Full-stack AI tools excel at the initial scaffolding, yet when the architectural logic fails, they frequently leave non-technicals completely stranded, staring at thousands of lines of code they cannot read. Rushing into code generation without a strict data plan trades a week of traditional coding for a month of debugging unreadable AI spaghetti code. Beyond the architecture of the database, the risk profile spikes exponentially when we look at a software application's highest risk elements: user authentication gateways and financial payment processing. Large language models operate by predicting the next most likely word based on historical patterns. They are structurally ill-suited for establishing secure defaults. They regularly miss compliance guardrails or hard-code administrative credentials directly into the application's plain text. This introduces specific, catastrophic vulnerabilities. If you don't explicitly tell the AI to validate user inputs, it will build login forms susceptible to database injection flaws, where a user can type a malicious command into a password box and delete your entire database. The resulting software functions exactly like this vault. The interface presents a heavy, impenetrable door, while the concrete wall beside it silently crumbles into dust. Frictionless feature deployment becomes a catastrophic business liability the moment it is allowed to bypass traditional security bottlenecks. Even experienced software developers are navigating these trade-offs. many are adopting AI-first IDEs to accelerate their daily workflows. An IDE, or Integrated Development Environment, is a specialized software application where programmers write and test their code. The efficiency gains here are measurable. Engineering teams utilizing AI tools report a 30% increase in pure development speed over traditional methods. But that speed comes with a hidden architectural cost, known as code churn. This is a metric where AI-generated code is rewritten, abandoned, or discarded at twice the normal industry rate within 2 weeks of being generated. This bar chart comparing lifecycle costs reveals the hidden trade-off. You get a low time to MVP on the left, but applications built primarily through vibe coding typically consume up to 4 times more server resources than meticulously hand-coded applications. For businesses looking to scale, the upfront financial savings of rapid AI coding are often erased by bloated maintenance requirements and higher server costs later in the product's life. Vibe coding is an incredibly potent translation layer between human intent and machine execution. It is not a replacement for software engineering. To extract the value without destroying your product, you need strict rules of engagement. This decision tree shows you how to map your project to the correct AI tool based on 2 variables: your project's risk profile and your actual technical skill level. If you are a non-technical founder building a low-stakes prototype to validate a market idea, you follow this path to full-stack builders. These tools will handle the hosting, the database, and the interface for you. However, there is a non-negotiable rule. You must never allow AI code to touch sensitive customer data or complex payment processing without a traditional developer auditing the data layer. If you are an experienced developer building a core business application, you take this alternate path. You use the AI as a strict workflow accelerator to write boiler code, the standard code sections that are repeated in many places with little variation, and generate test suites. The strict rule for developers is to treat the AI as an eager but unreliable junior engineer. Every function it suggests must be aggressively audited to ensure it hasn't pulled deprecated or insecure protocols from its training data. Honestly, matching your actual skill level to the right tool category is the only way to prevent these prototyping superpowers from becoming fatal liabilities. The software industry is entering a state where the raw speed of code generation is no longer the primary bottleneck in creation. Precisely because code generation is now effectively free, human judgment, architectural context, and ethical discernment have become the premium differentiators. Knowing what to build and ensuring it is built safely matters more than how fast you can generate the syntax. The most successful creators will be those who master this relationship, steering and shaping the raw power of AI generation with deliberate intention. Use vibe coding to design your outcomes and map your workflows, but rely on traditional engineering to secure, optimize, and maintain them.